Hey everyone, thanks for opening up your Science Sketchbook. In this video, we're going to be talking about bondline structure. This is a very fundamental concept for understanding how molecules look in organic chemistry. So let's go. Oh, looks like Sketch here is giving you a little bark warning. That means there's some background and review knowledge that you may need to brush up on to totally grasp this concept. He recommends checking up on that octet rule from general chemistry if anything feels confusing here. Alright, so let me give you some background on bondline structure. It's basically just a simplified way of drawing molecules containing carbons and hydrogens. Since organic chemistry is all about carbon, it can be a bit tedious to draw out all the atoms every time. So these structures will be looking like zigzags, branched structures, shapes, or molecules that have other atoms too. Notice how only some carbons and hydrogens are labeled? Well, let me show you how to find all of them, even the hidden ones. So you can kind of just view each molecule as a little road to carbon. There are corners, intersections, dead ends, and highways. So let's check it out. The corners are any little peak or bend in the road. Intersections are any point where there's kind of a fork or a split off. Dead ends are any point where the molecule road doesn't continue. And highways, they're a bit weird. Notice how that triple bond is kind of just an extra straight or longer road? People tend to forget that there is a carbon right there in the middle. So view that extra long portion there as a highway. You might be wondering about the tips of these lines. Well, these don't count as carbons because these lines lead to some other distinct atom that would be drawn there. So it's basically just some oxygen standing in the middle of the road, so nothing needs to be labeled there. Alrighty, awesome. So here we can see all of our carbons laid out. We have 9 of them total. We don't know how many hydrogens we have just yet, but we do know that we have 1 oxygen. So how do we know how many hydrogens are there? Well, let's take a closer look. Oh, remember when Sketch was barking about that octet rule? That concept is going to help you find where those hydrogens are. Let's look at this highlighted carbon here. Basically, a lot of atoms want to manage 8 electrons max, especially those in the second row of the periodic table. Let's see what this carbon has. Each bond line is equal to 2 electrons. So, check it out. This carbon has 4 lines, and that means that there are 2, 4, 6, 8 electrons. Wow, look at that. This carbon is already good to go. It has its full octet, so nothing needs to be added here. Let's try another carbon. So this one over here has 3 lines shown. That's 2, 4, 6, but not 8. So we kind of want to assume that everyone has their full octet here. But this carbon is missing something. So carbons have a special trick up their sleeves for when you don't see that full octet. Whenever you're missing a bond line, carbon has what's called an implied hydrogen. This is essentially a secret hidden hydrogen that just wasn't drawn in. So for however many bond lines you're missing, you can just add a hydrogen. So with that extra bond line in view now, you've got 2, 4, 6, and 8 now. So it was all set. It had its octet all along. This rule is going to apply to everyone. Look at this next carbon. It has 2 bonds connected to it, so it needs 2 more. With those hydrogens added in, that's 2, 4, 6, 8. This one next to it has 1 bond connected to it, so it needs 3 more. And there it is, 2, 4, 6, 8. What about this highway carbon? Well, it does have its 4 bonds already, so those are its 8 electrons. Nothing needs to be added. So as you can see, all these carbons just get a hydrogen depending on how many more lines they need. So that's the major tip here. Carbon just usually wants to have 4 lines in bondline structure. Just add in your implied hydrogens to complete that amount. So what about this oxygen? Well, remember, only carbon and hydrogen are close like that. Oxygen doesn't just get implied hydrogens too. That is solely reserved for carbon. But as it's shown, it only has 2 lines, so only 4 electrons in view. To show the complete octet, other atoms have a different solution to this problem. This is where you can add something called a lone pair. 1 pair is worth 2 electrons. So with a couple of lone pairs added in, we can see all of the pairs of electrons on this oxygen. And that does add up to 2, 4, 6, and there's 8. It has its full octet. So that's that. This is your final molecule all filled out. See how that's kind of messy though? That's why we have that simplified form without everything drawn in. But if you were asked on a test or a homework question or something, you'd know you have 9 carbons, 14 hydrogens, and 1 oxygen. Thus, if asked for the chemical formula, you'd say C9H14O. Awesome job! So there is one more brief thing to look out for, and that's a positive charge, or cation, on a carbon, so a carbocation. I want you to view them as a vacancy sign. That means there's a missing hydrogen where you might expect one to be. So let's label in all our dead end, intersection, and corner carbons. Alright, so let's take a look at that corner. Notice how it has 2 bond lines on it. So it needs 2 more lines to get those 4 total that carbons like so much. Alright, well, what about this one? It has 1, 2, 3 lines. So you may be expecting to add a hydrogen there to get the 4 total bond lines. But look, there it is, a plus sign on a carbon. That means that there is a vacancy. So there will be 1 less hydrogen than expected. So you actually don't have to fill in anything else here. No other carbon has any indication of a vacancy, so the others just get their 4 lines. So in total, that's C5H11. Without that vacancy there, it would have been C5H12, for example. So yeah, awesome work. Before we try some practice problems, let's do a brief recap. So, in bondline structure, carbons are the corners, intersections, dead ends, and those weird extended triple bond highways. In terms of showing a full octet, only carbon gets those invisible implied hydrogens to complete that set of 8 electrons. Everyone else gets lone pairs if needed. So to know how many of those implied hydrogens to add, remember that carbon usually just has 4 lines connected to it in bond line, so you can fill in any missing bonds with a hydrogen. However, remember to view a positive charge on carbon as a vacancy sign. That just means 1 hydrogen isn't home right now. Alright, so to really finish up this concept, let's try some practice problems. I want you to fill in any missing lone pairs or implied hydrogens. Then, write the chemical formula including the total numbers of each atom. Sketch has his pause up to suggest you pause the video here to give it a go. I'll give you a second to do that, and then we'll rejoin for the answers. Alright, you ready? Well, there you have it. Check over your answers and let me know how you did. All your carbons have their 4 lines, except that positive one on the bottom, and all your lone pairs are accounted for, so looks like we're all good. If you feel like you did really well, that's amazing and great job. If not, that's alright. Feel free to drop a question in the comments below and I'll try to help you out. Alright, with that, thanks for watching. If you want to learn more, check out some related organic chemistry topics in the playlist. Otherwise, Sketch hopes to see you around soon, and I'll catch you later. Bye!